What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to look at lesson 3.10, which is perpendiculars and distance. So how can we use perpendicular lines to find the distance between a point and a line? How to find the distance between parallel lines using perpendicular distance. First thing we're going to look at is distance between a point and a line. I'm going to go ahead and draw a picture first. So just think about this as one straight line. And then point C will be out here with, we're also going to mark this with a right angle. Okay, so today we're going to be focusing on how to find the length of CD or something similar. So the length of the segment perpendicular to the line from the point. So in this case, looking at point C to D. And the perpendicular postulate just states there exists exactly one line through the point that is perpendicular to the given line. Okay, so we're going to try an example, and this is how we're going to walk through this. It says line M contains the point 1, 2, and 5, 4. Find the distance between line M and the points 1, 7. So first we're going to graph the line and calculate the slope. So line M will be over 1 up 2, and then over 5, 1, 2, 3, 4, 5, up 1, 2, 3, 4. Now, what was interesting is in order to calculate the slope, we can do rise over run here. So it looks like we're going to have rise to run 4, which means my slope is going to be 1/2. That means I can continue this line, like maybe go up 1 over 2, just to give me a few more points. Down 1 over 2, down 1 over 2. Okay. And then I'm going to try my best here to draw a straight line. Ooh, there we go. Okay. Then we want the perpendicular slope. So the perpendicular slope is going to be -2. Okay. Plot point P and count using our perpendicular slope. So point P is 1, 7. I'm going to do this in a different color. Over 1, up 1, 2, 3, 4, 5, 6, 7. And then to show my perpendicular slope, I would be going down 2 over 1, down 2 over 1. Okay, here's point P. This was line M. So point P is going to be from here to here. So this would be maybe our distance. So plot point P and count using perpendicular slope. And now we want to find the distance between point P, which is 1, 7, and our new coordinate, which is now 1, 2, 3, up 1, 2, 3. Okay? So new is 3, 3. So now we would just find the distance of those using our distance formula. I'm going to do x2 minus x1, so 3 minus 1 squared plus 3 minus 7 squared. 3 minus 1 is 2, 2 squared is 4, 3 minus 7 is -4, and -4 squared is 16. So I'm looking at the square root of 20, which is about 4.47. Okay, we're going to try that same thing here. Find the distance between the points 2, 6 and the line -2, x. So first we want to write down our points 2, 6, over 1, 2, up 1, 2, 3, 4, 5, 6. And then I'm going to graph the line negative 2x. So negative 2x just means I'm going to start here at 0 as my y-intercept, and my slope is down 2 over 1, down 2 over 1, up 2, left 1, to create this line. Okay, pink line is gonna look like this. And right now, my pink line slope is negative 2. So to get perpendicular slope is going to be 1 over 2. So from that blue dot, I'm going to show up 1 over 2, but that's moving in the opposite way of my line, so I'm going to go down 1 to the left 2, down 1 to the left 2. Okay, so my point P is 2, 6, and I'm going to try to find the distance to this point, negative 2, 1, 2, 3, 4. Okay, so the distance between those, again, let's use that distance formula. I'm going to do 2 minus negative 2 for my x2, x1, plus 6 minus 4 squared. 2 minus negative 2 is 4 squared, and 6 minus 4 is 2 squared. Looking kind of like the one we just figured out. 16 and 4, adding those together gives me 20, so the square root of 20 is about 4.47. Okay, and then last one, find the distance between the points negative 6, 3 and the line x is equal to negative 1. So this one's actually going to be a little bit easier. Negative 6, 3 is to the left, 1, 2, 3, 4, 5, 6, and up 1, 2, 3. And then x is equal to negative 1 is a vertical line. So here's my x equaling negative 1. So for this one, and notice how it's an undefined slope, it is a little bit easier to calculate distance. So to go from my point negative 6, 3 to x is equal to 1, I'm just making a perpendicular line, which would be horizontal, and I can count these tick marks. 1, 2, 3, 4, 5. So in this case, I would see 5 units. Okay. Now, what I could do is I could still use this and say that my points are negative 6, 3 and negative 1, 3. But when I plug these into my distance formula, I would still get the same thing. Negative 1 minus negative 6 squared plus 3 minus 3 squared. That's going to give me 5 squared and 0 squared, or 25, which still gives me 5. Okay, so when you have horizontal and vertical lines, those are a little bit easier to find the distance from, just because it's easy to find the perpendicular lines to that. That'll conclude our notes today on 3.10. Hopefully this video gave you a little bit of help about how to find the distance between lines and their perpendicular lengths. Tune in next time when we get ready to review for our Unit 3 test. Have a great day.